Welcome to Quiet Learning. In this video, we take a calm, unhurried look at how roads are built, from the earliest planning decisions, through the layers beneath the surface, to the materials that quietly support everyday travel. There are no visuals you need to focus on, and no information you need to remember. This explanation is designed to be listened to gently, whether you are resting, working, or simply curious about how familiar infrastructure is made. Roads are among the most familiar pieces of infrastructure, yet their construction is a carefully staged process that balances engineering, material science, safety, and long-term durability. While the finished surface may appear simple, a modern road is built as a layered system designed to manage weight, water, and time. Before any physical work begins, engineers study the land where the road will be built. This includes the natural slope of the ground, the type of soil present, how water flows through the area, and how the road will be used. A lightly trafficked residential street is designed very differently from a road that must carry heavy freight vehicles every day. These early decisions influence everything that follows.
Choosing the route of a road is a careful process that often takes years before construction begins. Engineers and planners compare multiple possible alignments, assessing how each option interacts with the surrounding environment, existing buildings, and natural features. Steep slopes, flood-prone land, unstable soil, and protected areas are typically avoided where possible. The goal is to find a path that balances safety, cost, long-term performance, and minimal disruption. Traffic demand also plays a major role in route selection. Planners estimate how many vehicles will use the road now and in the future, and how those vehicles will connect with other roads. Curves, intersections, and gradients are designed to suit expected speeds and vehicle types. In developed areas, route selection must also consider noise, access to properties, and the movement of pedestrians and cyclists. Once a route is confirmed, the site is prepared. Vegetation, rocks, and existing structures are removed to expose the natural ground beneath. This stage is called clearing and grubbing. The exposed soil is then shaped to the planned height and slope of the road. This process, known as earthworks, creates a stable formation that the rest of the road will be built upon. The natural ground is rarely suitable to directly support traffic loads. Soil can shift, compress, or weaken when wet. To address this, the ground is compacted using heavy rollers that press the soil particles closer together. In some locations, unsuitable soil is removed and replaced with stronger material. In others, the soil is stabilized by mixing it with lime, cement, or other binding agents to improve its strength and resistance to moisture. Water is one of the greatest enemies of a road. If water becomes trapped within the structure, it can weaken the layers and cause cracking or deformation. For this reason, drainage is designed early and carefully. Shallow slopes are built into the road surface to guide water toward the edges. Beneath the road, drainage layers and pipes may be installed to carry water away safely. With the ground prepared, the first structural layer of the road is placed. This is often called the subbase. It is typically made from a mixture of sand, gravel, and crushed rock. The exact composition depends on local material availability and ground conditions. In some cases, natural sand or clay soils are blended with crushed stone to improve compaction and drainage. Recycled materials, such as crushed concrete or reclaimed asphalt, may also be used where suitable. The subbase spreads vehicle loads over a wider area and provides a stable, well-drained platform for the layers above. Like the soil below it, this layer is compacted thoroughly to remove air gaps and increase strength. Above the subbase sits the base course. This layer is made from higher quality, well-graded crushed rock with tightly controlled particle sizes. The stone fragments are angular rather than rounded, allowing them to lock together under compaction. Small amounts of fine material, including sand or clay-sized particles, may be present to help bind the larger stones, but excessive fines are avoided because they can trap water. In some designs, the base course is stabilized with cement, lime, or bitumen to further increase strength and durability. The base course carries most of the structural load of the road and plays a major role in how long the road will last before major repairs are needed. At this point, the road may look complete, but the surface layer is still to come. The surface is what vehicles directly contact, and it must provide grip, smoothness, and resistance to weather. There are two common surface types, asphalt and concrete.
Asphalt roads are built using a mixture of crushed stone and bitumen, a thick black binder derived from oil. The mixture is heated and laid while hot, then compacted with rollers. As it cools, it hardens into a flexible surface. Asphalt can expand and contract slightly with temperature changes, which helps it resist cracking. It is also relatively quick to repair, making it common for urban roads. Concrete roads are built differently. Wet concrete is poured into prepared forms and smoothed into place. As it cures, it hardens into a rigid slab. Concrete is very durable and can handle heavy loads well, but it takes longer to construct and repair. Expansion joints are added to allow for movement as temperatures change. In both cases, the surface layer is carefully shaped to ensure proper drainage and a comfortable driving experience. Even small variations in slope or texture can affect safety, especially at higher speeds or in wet conditions. Once the surface is complete, additional elements are added. Road markings are applied using reflective paints or thermoplastic materials. These guide drivers and improve visibility at night and in poor weather. Signs, barriers, and lighting are installed where required. Shoulders and surrounding land are stabilized to prevent erosion. Quality control continues throughout the entire process. Materials are tested for strength and consistency. Compaction levels are measured. Surface smoothness is checked using specialized equipment. These checks help ensure the road performs as designed, not just when it opens, but years into the future. After construction, a road enters its longest phase, use and maintenance. Traffic, weather, and time gradually wear down the surface. Small cracks may appear, and the surface can become polished or uneven. Regular maintenance, such as sealing cracks and resurfacing, extends the life of the road and delays more disruptive reconstruction.
Modern road design increasingly considers noise, environmental impact, and sustainability. Some surfaces are engineered to reduce tire noise. Recycled materials may be incorporated into asphalt. Drainage systems are designed to protect nearby waterways. These considerations reflect the evolving role roads play within broader communities and environments. Though often overlooked, roads represent a balance between engineering precision and practical compromise. They must be strong but economical, durable but repairable, and safe under a wide range of conditions. Each layer beneath the surface quietly performs its role, supporting millions of journeys without drawing attention to itself. In this way, a finished road is less a single structure and more a system, one designed not only to carry vehicles, but to endure weather, manage water, and quietly serve its purpose over many years. This has been a quiet explanation of how roads are built. If you found this explanation helpful, you may enjoy other quiet explorations of how everyday systems work, told slowly and without distraction.
Thank you for listening. This is Quiet Learning.